Hello, welcome to your lesson on integration with sine and cosine. Hey, if you haven't laughed yet today, how about pausing the video now and just reading this joke? Okay, let's get started on our lesson. To begin, we are going to take a flashback. We're going to travel back in time to when we learned about integration. Okay, so when we looked at integration, our introduction was this, that we have something called, we have a function, and if we take the derivative of that function, we go like this. So there's a derivative. But when we go backwards to there, that's called an antiderivative. So the reverse of finding a derivative is known as finding an antiderivative, and that's what integration is. It's finding an antiderivative of a function. So let's take a look at it here. What would be the antiderivative of this function here, 2x? Let's say you have this function. Okay, we're going to apply our basic rule of, well, first of all, to find that, we're going to take the integral, right? Finding antiderivative means take the integral. So we're going to take the integral of that. And finding the integral of that, we're going to use the most basic rule of integration called the power rule. Let's remind ourselves how that works. When you have an integral of a function with a power, all you do is we do the reverse of a derivative. In a derivative, we would subtract 1 from the exponent, right? But in this case, we add 1 to the exponent. And then we multiply by 1 over that new number. Okay, that's the rule we learned because that undoes the derivative. Okay, let's check how that works here. So here we have a power of 1 on the x right now. So what we're going to do is add 1 to that, so that power becomes 2 now, and then multiply that whole function, 2x squared, by 1 over this number here. Okay, there's a lot of 2's there, so it might be confusing, but that 1 over 2 here comes from this exponent here. Okay, but that half and the 2 cancel, and we're left with just this. Now, we always wrote it with plus c. When we had an indefinite integral like this, we wrote plus c. Why? Let's remind ourselves of why that we have that c. Okay, so let's say we had a function, f of x equals x squared. If you took the derivative of that function, it would be 2x. Great. But are there other functions that can produce the same derivative? Well, there are. Let's say we had another function, g of x, and it was x squared plus 4. If you take the derivative of that, you get 2x as well, because the derivative of 4 is 0. So notice two different functions produced the same derivative. So that means when we go backwards, which is integration here, we have to show that there's more than this one possibility. There's more than just x squared that will lead to 2x. There's x squared plus a constant, or any constant. Basically, that number can be any number. So we have infinite possibilities, and that's what this shows us, that there's infinite possibilities. Okay, with that basic reminder of integrals, let's keep going. So we were showing the idea of derivatives and integrals being reverse processes. So here we have a derivative of x cubed, and we know that equals 3x squared. Now to show that as a reverse process, we go like this. Integral of this result takes us back to the original x cubed, but we add the c. Okay, so try that. It's shown here again. Try that filling in the blanks here. So let's look at the first one here. What would you put in those two blanks? Okay, next one, what would you put in those two blanks? And last one, what would you put in these blanks? Okay, so here's the answers. Double check your work carefully, and let's point out something important at the end here. First of all, the derivative of sine is cosine. Therefore, the integral of cosine is sine. We're going backwards. But over here, why did they choose to put negative cosine? Well, the reason is this, right? We know the derivative of cosine is negative sine x. So if we just had cosine here, it would be negative sine x here. But we want to figure out what is the integral of cosine and the integral of sine. So the only way to get to sine is by starting with a negative cosine. That becomes sine x here because the negatives cancel, and therefore the integral of that is negative cosine. So we've just discovered what the integrals of cosine and sine are, and we have to memorize those just like we memorized the rules of derivatives for those. So let's recap the rules. We have our power rule for integrals, the basic rule about raising the power and then multiplying by the fraction. And we also looked at integrals of 1 over x, which we recognize as ln x because the derivative of ln x is 1 over x. So that's the reverse process there. And also the integral of e to the x is e to the x because, again, we know the derivative of e to the x is itself. So those are shown there. Now we've added integrals of sine and cosine to that. So again, the integral of sine x is negative cos x, and the integral of cosine is sine x. Okay, what about this idea about having functions that are composed with linear functions? So you may remember something like this. Here we have a function on the outside. It's just a power function with n, but inside that function is another function. So it's kind of like well, it's a composition. We have one function put inside another one, but the function we've put inside this power function is a linear function right here. So you may remember the rule for that works like this. So here we have that again. We have a power function, and inside of it we have a linear function. And the rule was we do this. We apply our basic power rule. So ignore the inside for a moment and look at the outside power function. We add 1 to that exponent, and then we multiply by 1 over that power raised by 1, right? So that's our basic rule. But within there we have this linear function, so we have to remember that we also have to multiply by 1 over a, which is 1 over that coefficient. So you may remember that rule. We need to have that extra multiplier fraction there because of this linear function and that coefficient. So let's apply that to sine and cosine as well. So once again, linear function inside another one, we have to deal with it by putting 1 over a like that. Okay, so with sine and cosine, here's how it works. And in many ways, this is a little easier because we don't have a power here. So we have a sine function, but within that sine function, we've inserted or composed in a linear function. So to find the integral, we're going to do the integral of the outside function, which is just sine, and the integral of sine is negative cosine. We can see it here. But since we have a linear function within the sine, we have to then also multiply by 1 over a. So you can see that there. We have that linear function right here. Therefore, at the end, after taking the integral of the outside, we have to also add the fraction 1 over a. Okay, let's look at cosine. Same thing. Here we have a cosine function, but there's a linear one put into it or composed into it. So the integral of the outside function, integral of cosine, is sine. And since we have a linear function within it, we have to multiply by 1 over that coefficient. So we have that there. All right, so pretty simple. Let's try it out. And let's see why that rule works first, because we should remind ourselves why this linear rule works. Okay, let's say we begin with this function here, and you were told to find the derivative of it. Okay, so let's find the derivative of this. The derivative of this will be 1/5 times the derivative of sine of this. Okay, so here it is. 1/5, and the derivative of sine is cosine. So 1/5 cosine of that function. And then by chain rule, since we have a function within a function, multiply by 5, because that's the derivative of the inner function. Okay, so the 1/5 remain there because a constant just remains outside, a constant multiplier, coefficient. Then sine derivative is cosine times derivative of the inside one. Okay, and then what happens to 1/5 and the 5? Well, they cancel like this, so they're gone. So now we found out the derivative of this is actually this. Now going backwards, we could find the integral. So the integral of this, we know now because we've done this process, the integral of that must be what we began with here. So that's what I wrote here. And notice then the integral tells us we have the integral of cosine, which is sine, but then we're multiplying by 1/5 because of that linear component. We need that 1/5 there. And we see here it works because the derivative gets us there and then backwards gets us back to the beginning. So that 1/5 is important. Pause and kind of study that if you need to. Okay, now let's try some of these. First one's going to be a simple one. There's not even a linear function in there. Okay, so take that integral. What do you get? Okay, check your work here. The 2 can just come out. By rules of derivatives and integrals, when we have that constant coefficient number, we can just take it out. Integral of cosine is sine, so there's our answer. Okay, try B, which does have a linear component. Okay, by that rule we just looked at, we take the integral of sine, which is negative cosine, and since we have a linear function composed in there, we multiply by 1 over 3, which is 1 over that number. Alright, try C. Okay, in C, we can bring the 4 out again as well. Then take the integral of cosine, which is sine. Now we have that 4 there, but this one has a linear component in there. 4x is a linear function. So we need to multiply by 1 over 4 because of this. So there's that 1 over 4 because of that. And there's that 4 right here. Those cancel and you're left with this. Okay, hope those basic examples help clarify how to find these integrals. Let's try some more. So here's some more taken directly from our practice assignment. How about you try 1, 2, 3, and 4 first. Try 1, 2, 3, 4, and then we'll check the answers. Okay, here's the answers for 1, 2, 3, and 4. Check how you did. Check exactly what's going on here. And come to our next lesson with some questions if you have them still. Okay, now try 5, 6, 7, 8. And now check your work for those. So there's the answers. Check carefully how you did. If you see something you're not sure about, again, be sure to let me know. Great work. After this, we're going to have another video. So great start, but there's a key video coming up. Make sure you watch the next video as well before our next lesson. We'll see you soon.